Hello friends, I am going to discuss about the case study on spray freeze drying approach for soluble coffee processing and its effect on quality characteristics. Introduction. Coffee is the world's most widely traded tropical agricultural commodity with its process innovations evolved and emerging across years. Soluble coffee refers to the coffee powder obtained from freshly roasted and ground pure coffee beans. According to FSSAE 2020, not 2000 to 2011. Spray drying (SD) and freeze drying (FD) are the conventional soluble coffee manufacturing techniques, while SD is established as the most economical process for commercial production. FD provides product with superior aroma quality. Nevertheless, SD and FD are associated with some limitations. Spray drying exhibits possibilities of losing certain characteristic low boiling aromatic compounds in coffee due to its high temperature operation. Freeze drying process is energy intensive and expensive owing to its low temperature, that is minus 40 to 50 degrees Celsius, and low pressure 30 to 40 Pascal operation. Consequently, freeze drying of aqueous coffee extract requires longer drying time in the order of 8 to 16 hours. SFD spray freeze drying technique possesses the main merits of SD and FD, that is spray drying and freeze drying, and can overcome the challenges aforementioned. Spray freeze drying involves atomization, freezing, and drying of the feed solution. The minute droplet resultant from atomization offer more homogeneous temperature field for heat transfer during the spray freeze step, which leads to uniform nucleation and formation of fine ice crystals. In the freeze drying step, an enhanced sublimation rate is facilitated by reduced product dimension. The consequent increase in surface mass transfer coefficient leads to a reduction in total drying time, and eventually it results in fine and free flowing powder. Objective. The main aim or the objective of this research work is to evaluate the suitability of spray freeze drying as a soluble coffee processing technique with comparatively with spray drying and freeze drying. The present work comprises of a detailed comparative study between the spray freeze drying and spray drying coffee samples for their aroma profile, volatile retention, solubility, morphology, particle size analysis, and flow characteristics. Materials and methods. First, about feed solution preparation. We should dissolve commercial instant pure coffee powder in distilled water at a mass fraction of 40% water per water, that is volume per volume of the solution. Sorry, W by W means weight per weight, 40% weight per weight of the solution. Spray freeze drying. It comprises of a twin fluid nozzle, peristaltic pump, and polystyrene container connected to a liquid nitrogen dewar. A disc blade impeller is used for mixing the contents. The distance between the nozzle and the liquid nitrogen, it was about 10 cm. A twin fluid nozzle atomizer was used with compressed air pressure for of about 588.39 kPa. The feed flow rate was set at 6 milliliter per minute. There are two temperature ranges, one is for primary drying and second is for secondary drying. In primary drying, the temperature range is about minus 25 degree to minus 10 degrees Celsius under vacuum at 107 pascals. The secondary drying is at 10 degrees Celsius under a vacuum of 40 pascal. After that, it is packed in polyethylene bags, sealed and wrapped in aluminum foil. Later, it is then stored in a desiccator at an ambient temperature, that is room temperature. Then we are going to discuss the next two, spray drying and freeze drying. In spray drying, it consists of a single stage short type pilot scale spray dryer. It consists of a twin fluid nozzle. The inlet air temperature is at 150 degree plus or minus 2 degrees Celsius, and the outlet air temperature is at 100 degree plus or minus 2 degrees Celsius. The coffee powder was packed in polythene bags, sealed and wrapped in aluminum foil, and it is stored in desiccator at the ambient temperature. As for freeze drying, it's a pilot scale freeze dry, that is, it is automatic in nature. The coffee powder is packed in polythene bags, sealed and wrapped in aluminum foil, and stored in desiccator at the same ambient temperature. The other parameters for analysis include moisture content determination, headspace analysis for using electronic nose, volatile identification, solubility, morphology, and particle size analysis. Now coming to results and discussion. This table, it gives the comparison of physical characteristics between spray freeze drying, and spray drying of coffee samples. These are the three drying methods. In the table, you can see spray freeze drying, SFD, FD, and ST. First, we'll see the moisture content. The moisture content of spray freeze drying and freeze drying coffee samples were higher than that of spray drying. That is, moisture content that in wet basis is 8.665 for spray freeze drying, and FD is 8.84, which is higher than spray drying. As for particle size analysis, the mean volume was greater in diameter in SFD over ST. That is, mean volume was 91.1 micrometer in SFD spray freeze drying than freeze drying, that is 636.8 micrometer. As for solubility of spray freeze drying, it exhibited more instantaneous solubility because it has less soluble time, that is 11 seconds, 11 plus or minus 1 second. Comparatively to freeze drying and spray drying, it were 22 plus or minus 1 and 20 plus or minus 1 seconds. Then electronic notes. In this there are 4 plots. That is electronic note analysis. A, it denotes commercial instant coffee. B denotes spray dried coffee. C denotes fried dry coffee, and D denotes spray dried SFD, spray freeze dried coffee. The PCA plot, also called electronic notes plot, it represents 89.49% of the variation in data as explained by PC1 and 7.63% of the variation by PC2. The spray freeze drying and freeze drying coffee samples were similar in terms of their order profile due to their low temperature operation. The spray drying coffee formed a very discrete cluster from the other samples. Then about volatile retention analysis. Accordingly, the compounds chosen were: first one, it is methylpyrazine A, acetic acid B, 2,3-butadiene C, pyridine D, 2-furanmethanol E, and maltol F. On an average, according to the volatile retention analysis, spray freeze drying coffee, it retained 93% of the marker volatiles that were present in the feed material, followed by 77% and 57% retention with FD and spray drying coffee respectively. Then morphology. According to the morphology, spray freeze drying coffee particles, it depicted a high porous and rough surface with a spherical shape. ST sample exhibited smooth and spherical shape, but although in freeze drying coffee it was relatively less porous than SFD with flaky structure. Here is the diagram that you can see the morphologies. Then conclusion. In the present study, it shows that the spray freeze drying, it shows a better aroma quality by retaining the characteristic low boiling aromatic compounds of coffee that were lost during the initial stages of freeze drying and spray drying. Hence, SFD, spray freeze drying, it can be potentially employed for the production of soluble coffee with improved product characteristics. Thank you.